Here's example 3 with evaluating half-angle formulas. So here we want to evaluate the tangent of 9 pi over 8. So we're going to turn to our half-angle formula sheet here. So if you want to copy this formula sheet, check the video description. There's a link in there. You can click that link, open this up, get a copy. So here we see, the idea here is to express 9 pi over 8 as half of some special angle that we know stuff about. Okay. So here we see there's 3 possibilities to use. Tangent of alpha over 2 is this guy or that guy or that guy. And we'll talk about which one to pick later on. But first, let's figure out, okay, what is our alpha going to be? What's 9 pi over 8 is half of what? So 9 pi over 8 is 1/2 times what? So if we multiply both sides by 2, then what we get is 9 pi over 4 equals our question mark. Okay, so that's going to be our alpha right here. All right, so what we have then is tangent of 9 pi over 8 equals tangent of 1/2 times 9 pi over 4. Okay. So if we go back to our formula sheet here, we see tangent of alpha over 2. So alpha over 2, that's the same thing as 1/2 times alpha. So dividing by 2 is like multiplying by 1/2. So this 9 pi over 4 right here, that is our alpha. Okay, that's going to be our alpha. Okay, now the question is, which of these three formulas do we use? The first one, if we can avoid using the first one, definitely avoid it, because it's got the square roots, it's got the more complicated top and bottom, and it also, the worst part is it has the plus minus sign, and we have to be careful about the quadrant that we're in. So if we can avoid using that first one, definitely avoid it. So between the second and third one, it's better to use the second because it only has one term in the denominator. Okay? And usually that's better because it's easier to simplify based on that. So let's use the second one here. So tangent of alpha over 2 is 1 minus cosine alpha divided by sine alpha. So this is going to be 1 minus cosine of alpha, and remember alpha is 9 pi over 4, divided by the sine of alpha, which is sine of 9 pi over 4. Okay? So now we just have to know the unit circle and some properties of trig. So if we think, okay, 9 pi over 4, that's not really a special angle on the unit circle, right? But let's think about this for a sec. 9 pi over 4, that's kind of big, right? It's a little bigger than, so 9 pi over 4 is actually bigger than 8 pi over 4, and 8 pi over 4 equals 2 pi. So actually 9 pi over 4 is bigger than 2 pi. So what's that property we should use? It's the periodic property, okay? So what we can do then is say, okay, 9 pi over 4, let's subtract 2 pi and see what we get. Okay, well remember 2 pi is the exact same thing as 8 pi over 4. Okay? So 9 pi over 4 minus 8 pi over 4 equals pi over 4. Okay, so then what we have is, remember that word is coterminal. These are coterminal angles. So if we were to draw them, this right here is pi over 4. Okay, this is pi over 4. But then if we go all the way around one full revolution, that's going to be 9 pi over 4. Okay, so pi over 4 is like this, and then 9 pi over 4 is all the way around back up to here, one full circle. So they're coterminal, and remember what the nice property about coterminal angles is if you have coterminal angles, the values of the trig functions at those angles are all the same. So in other words, cosine of 9 pi over 4, it's the same thing as cosine of pi over 4, because they have the same, because these two angles have the same terminal side. Okay? So this equals, and the same thing is true for sine. Sine of 9 pi over 4 equals sine of pi over 4, because 9 pi over 4 and pi over 4, they're coterminal angles. Okay? So this is 1 minus cosine of pi over 4 divided by the sine of pi over 4. Okay, and pi over 4, it's one of the nice angles on the unit circle that we do know. So then we can just say, okay, this equals 1 minus root 2 over 2, all divided by root 2 over 2. Okay, so then we have that going on there. Okay, so now 1 up here, let's get a common denominator here. So now what we're going to say is, okay, let's multiply this by 2 over 2. There's a few different ways we can go to simplify this, but let's maybe do it like this. So this is going to be, come up here, this is going to be 2 over 2 minus root 2 over 2, all divided by root 2 over 2. Okay, so then this equals 2 minus root 2 over 2. Okay, and then let's do 2 steps in 1 here to save space. We're running out of space. So if we divide the whole top by root 2 over 2, that's like multiplying the top by the reciprocal, which is 2 over root 2. Okay, so we have that going on there. All right, now this equals, so now if we simplify everything, this 2 cancels with that 2, and then what we have is 2 minus root 2, all divided by root 2. Okay? Which would be totally fine if you were one of my students, but if you have to rationalize the denominator, then what you would do in this case, actually I think in this case it will simplify a little bit, so that is kind of nice. It doesn't always happen like that. But anyway, if we want to rationalize the denominator, so we'll multiply by root 2 over root 2, then we have to be kind of careful here. So let's come up here. So this is going. So we want to distribute on the top. So that's going to be on the top. If we distribute, then what we have is 2 root 2. Okay, 2 times that root 2, and then minus root 2 times root 2. And then on the bottom we have root 2 times root 2. Okay, so we'll just show all the details here. And then this becomes 2 root 2 minus root 2 is just 2. And then on the bottom we have root 2 times root 2, which is just 2. A lot of 2's. Okay. Now on the top we can factor out a common factor of 2, so that's 2 times root 2 minus 1. And then on the bottom we still have that 2. Cancel, cancel. So then this equals the square root of 2 and then minus 1. And that's our final answer there. Okay, so the square root of 2 and then minus 1, that's the final answer for the tangent of 9 pi over 8. Okay, so that's example 3 with using half-angle formulas. And I do want to point out, if we used either this first formula for tangent alpha over 2 or the third one, we would get the same answer. It is possible it might not look like this. We saw something like that in one of the earlier examples. In example 1, we did something 2 different ways, got the same answer twice, but it didn't look the same. You might get something that looks different, but it will be the same as long as everything is done correctly. So there's example 3 of using half-angle formulas to evaluate tangent of 9 pi over 8, and the answer is the square root of 2 minus 1.